Okay, in today's lesson, I'm going to teach you how to plot a graph on rate of reactions against temperature. Now, first of all, we need to read the question carefully. In experiment 1, a student investigated how temperature affected the rate at which an enzyme digested a protein. The experiment was repeated, but using double the concentration of the enzyme. The results are shown below. This column shows the different temperature. This column shows experiment 1. And this column shows experiment 2 that is based on the double concentration of enzyme. So today we need to plot two curves against temperature. Part A. We need to plot the results of experiment 1 and 2. Use smooth curves to connect the points for each experiment. Label each curve as 1 or 2. Please underline these keywords accordingly. Next, let us look at the graph paper provided. It is rate of reactions of the enzyme per minute versus temperature in degrees Celsius. Let us plot the points. Let us first plot curve number 1. The temperature is at 0. The rate of reaction is at 0 when the temperature is at 0. So 0, 0 for the first curve. So I may want to write first curve over here. So I go to the graph and plot 0. But before I do that, I need to indicate and label all the different points for temperature and for the rate of reaction. Now if I look at temperature, it spans from 0 to 45 with 5 degrees Celsius as an interval. 5, 10, 15, 20, 25 and so on. So I go to the x-axis and count. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 boxes. 1, 2, 3, 4, 5 with 5 small boxes in each point. So what I can do is divide 5 degrees Celsius for 5 small boxes. 1, 2, 3, 4, 5. 0, 5, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 40, 45, 50. So what I did here is I have an equal number of 5 small boxes for a temperature of 5 degrees Celsius. So I divide them equally to 5 small boxes and I indicate 5, 10, 15, 20, all the way to 50 degrees Celsius. as my data here requires to have a temperature from 0 to 45 with an interval of 5 degrees Celsius. Next, I'd like to plot the y-axis. Y-axis, I have to look at both data. It spans from 0 to 190. So what can I do to make sure that my y-axis spans from 0 to at least 190? Let's look at our curve here. What I can do is I can have a 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 10, 20, 30, 40, 50, 60, 70, 80, 90. What I can do is every 5 boxes will be a rate of 10 reactions per minute. So I repeat, I can have every 1, 2, 3, 4, 5 small boxes, 10 reactions per minute. So I'll divide these boxes equally, 10, 20, another 5 small boxes will be my 30, 40, 50, 60, 70, 80, 90, 100. Now, is this enough? I'll take a look at my data again. It's from 0 to 190. So I need at least 190 along my y-axis. So I continue. 110. Now make sure that all these are equal, meaning 5 small boxes for every 10 reaction of increment. 130, 140, 150, 160, 170, 180, 190, 200. Why do I put a 200 here? Because that's the end of my axis, although I just need 190 for my data. So I have my x-axis for temperature and my y-axis for rates of reaction per minute. I'm done with the axis and I start plotting my curve. First point for my curve, first curve, curve number 1. Curve number 1. 0, 0, which I did just now. Second point, at the temperature of 5 degrees Celsius, my curve 1 will be at 4 reactions per minute. 4 reactions per minute. Now how do I count here? I have 5 small boxes here for 10 reactions per minute. So every small box will be 2 reactions per minute. How do I get 2? 10 divided by 5 is 2. So every small box is 2 reactions per minute.